Hello class, this is lesson 1-13, Introduction to Integers and Signed Numbers, where we will be going over positive and negative numbers as well as the number line. This is the Learning Needed channel. My request to students in all videos is to remember your reason to pass the GED test and use that to motivate you to get that GED certificate. Don't give up, keep going, you got this, and please like and subscribe to this video and my channel so that I can produce more GED content, not just in math but in all four subjects, but also so these videos reach more people that might be looking to get their GED certificate. If you are interested in one-on-one tutoring where I work with you live on working on some practice problems, going over a subject you're having difficulties in, coming up with a study plan or anything to help you get that GED certificate, I do have that service available at my website, which is listed in the video description below. The material that I suggest students to use if they are looking for a resource is the Kaplan GED Test Prep Book. It looks like that purple book there. They release one every year, but you don't have to get the latest year to be up to date. They make a few updates every year, but for the most part, the material stays the same throughout. So if you are able to find an earlier version, an earlier year at a cheaper price, that should work as well. Also, for the GED math test, the only calculator that you are allowed to use is the TI-30XS model, which looks like the one there on the screen. And I highly suggest that you take some time to find one, even if you don't purchase one, to use for a little while so that you learn all the functions on the calculator so that you are not at a disadvantage during the test. If you are interested in getting the latest copy of the GED book or the allowed calculator, I do have links to purchase both of those in my video description below. All right, let's get started. Integers, by definition, are all whole numbers. They can be split into three categories, which are the positive numbers, zero, and negative numbers. Zero is a special case. It is categorized as an integer, but it does not fall under the categories of positive or negative. And by highlighting whole numbers, this means that decimals, which represent part of a whole, they do not count as integers. Number lines are a visual representation of integers and how they relate to one another. It looks like this line here. It is one horizontal line that goes from left to right, and the arrows at the end mean that it goes on forever. I have here listed a 0 in the middle, and I have notches that are evenly spaced between them. So if I fill in the rest of the number line and highlight what each notch means, then I am going from 0 to 1 to 2 in the right direction and 0, -1, -2 in the left direction. The things to point out here are that the positive numbers, they show the distance to the right from 0, and negative numbers show the distance to the left from 0. So the further you go to the right from 0, you are becoming more positive in value, and same in the reverse direction. If you are heading more left from the 0, you are gaining more negative value. Now, the number line, the spacing between them, they are evenly spaced. So the distance from 0 to 1 is the same distance from 1 to 2, and so on and so forth. And when you see it on the GED math test, it will be drawn more accurately, but it is understood that the space between them is the same throughout the entire number line. Signed numbers are all numbers that are either positive or negative, and by this definition, that means that 0 does not qualify as a signed number because, as we saw, 0 is neither positive or negative. Positive numbers can be written with or without the positive sign, and numbers without a sign can be safely assumed to be a positive number. So if you see just a number written out and there's no positive sign written in front of it, you can safely assume that that is a positive number. So let's look at some examples of positive numbers. Here we have positive 4, where the positive sign is explicitly written in front of the 4. Next we have 3. There is no sign written next to the 3, so we can safely assume it's a positive number. 25 has the positive number explicitly written, and then we have 1002 without the positive sign explicitly written. So all of these are positive numbers. As you've noticed, the positive sign looks like the addition sign, and that is because it is the exact same sign. So it is important to distinguish between the addition sign and the positive sign. The positive sign is only used to associate with a number. For example, this positive 4 they go together. It's the positive sign and the 4. It does not represent plus 4. that is a different syntax, even though it uses the same sign. And we'll see some examples of that in the video here. Negative numbers are written with this negative symbol. They are commonly written inside parentheses to distinguish between the subtraction sign and the negative symbol. So some examples of negative numbers here are -4. This one isn't written with the parentheses. The parentheses isn't a requirement to write the negative sign. It is just that it is very commonly used to differentiate between everything else that's happening around that number. Here we have -3. This one is written within the parentheses, so that is a very common way you'll see it. We also have -25, where it is not written with parentheses, and then -1002, where it is written with parentheses. So these are just different examples of how you'll see the negative numbers. Coming back to the number line, a number line is used to compare values to each other. Numbers on the left of the number line are less in value than numbers on the right. So let's look at an example. Let's say that we are asked to order the numbers 5, -3, and -1 from least to greatest. So first thing I'm going to do is I'm going to plot these 3 points on the number line. So let me draw a number line here, same one as you saw earlier with the 0 here in the middle. And I am going to go and plot these 3 points on this number line. Now I mentioned before that the spacing between each one is equal. And while we were not explicitly given the values of each notch, I can freely use them as it is best suited for this problem. So I don't need the first notch after 0 on the right to be a large number like 25 or 100. I can just say, hey, that first notch to the right of it equals 1. Because that's the value, or that's the range of numbers that I'm working on. I'm working with very small values, so I don't need to go very big on the values of each notch. So if I say that each notch is simply increasing in value, or the distance between them is 1, then to plot 5, all I have to do is count 5 spaces to the right from 0 to see where the 5 is. And that is placed here, 5 spaces on the right. And again, it's on the right because it's a positive value. Following that logic, -3 means that I am 3 spaces away from the 0 and I am on the left side. The negative sign means to the left of the 0, and the 3 means how far away from the 0. So it is 2 pieces of information that tell you where to put it on the number line. Again, sign tells you right or left from the 0, and the value tells you how far away in that direction. So following that logic, I count 3 spaces to the left from the 0, and I plot the -3 here. Same logic for -1. It is to the left because it is negative, and 1 space away from the 0, so it is 1 notch to the left of the 0, and now I have plotted these 3 points. To order these from least to greatest, all I have to do is write out in order the numbers as they appear from left to right, because again, the numbers to the left, the numbers on the left of the number line are less than the numbers on the right. So -3 is less than -1, and -1 is less than 5. So all I do is I write them going from left to right in order, and the answer here is -3, -1, and 5. So that was going over integers, signed numbers, and number lines. So let's now go through some examples. Which of these five choices are integers? And there may be more than one answer. So take a pause here and choose the answers or answer or none that you believe to be the integers. Go back in the video if you need to go through to the definition of integers again. So let's go from the top to the bottom. Let's start with answer choice A, 1.2. By the definition of integers, it is all whole numbers. 1.2 is a decimal, which represents a value that is not a whole number. Therefore, it is not an integer. B is 4. Since there is no sign written in front of the 4, I can safely assume it's a positive number, but it is a positive whole number. Therefore, B is an integer. Next, we have -3. -3 is a whole number, and it is a negative number, and it is not a decimal, so therefore it is an integer. D, 0. An integer is 3 items. It's a positive number, 0, or a negative number. 0 is a special case integer that it is not defined as either a positive or a negative number, but regardless of that, we are looking for the definition of integers, not positive or negative. 0 is an integer. So therefore, D is an answer choice. And finally, E, 3/8 is a fraction, and fractions represent values that are less than 1, or in other words, values that are not a whole. They are a part of something. Therefore, e is not an integer because integers are only whole numbers. So by those definitions and those explanations, I hope you got that b, c, and d are integers here. Next example. Let's order the following from greatest to least. Here are the four numbers: -4, +1, -3, and -5. Also, you may have noticed this now, but just like how you don't need to explicitly write a positive sign for positive numbers, you don't need to say out loud +1 if you say a number without the sign. If I only say 1, it is understood that it is a positive 1. To solve this problem, I'm going to plot these points on the number line above. Once again, the number line did not give me how to represent each notch, but with the range of values that I'm using, I can use that each notch in the number line is just simply a value of 1 away from each other. -4, using the two pieces of information, one, that it is a negative sign, means that it must be plotted to the left of the 0, and 4 means that I must plot it 4 spaces away from the 0. So following those two pieces of information, I plot the -4 here. Same with 1, it is a positive number, so to the right of 0, and 1 means 1 space from the 0, so I plot that here. -3, to the left of 0, 3 spaces, and -5, to the left of 0, 5 spaces. To order the numbers, I am going to write them from right to left because the question, unlike the example earlier, is asking us from greatest to least, not least to greatest. And again, numbers towards the right of the number line are greater in value than numbers to the left. That is why in this case, I write them as I see them from right to left. And the first plot that I see, or the first point that I see on the number line on the right is 1, followed by -3, -4, then -5. So the answer is that order. Now, let's plot these points: 14, -25, 7, -18, and 1. And if you'll notice, I did not say positive when I was saying the positive numbers, and that works just as well. So now I am going to use a slightly different number line than the one above. Here, I am providing you a number line, but I am telling you how to interpret each notch. Each notch in this case is 5 values away from each other. Unlike the number line above, where if I move 1 notch to the right of 0, that means I am 1 space away from it. If I move 1 notch to the right of 0, I am now 5 spaces or 5 values away from 0. In other words, in between the 0 and 5, I have the values in between of 1, 2, 3, and 4. And if I'm plotting points, I keep it within reference to each other as shown here. So I'm going to plot the first point, 14. It is a positive number, so I plot it to the right of 0, and I plotted 14 spaces away from the 0. Now there is no notch specifically for 14, unlike the previous number line, but I know where it is in reference to the numbers that I am given. For 1, I know that it is somewhere between the 10 and the 15, right? Because 14 is between 10 and 15. But where in that space in between I put it is simply where it is in reference to those two numbers. 14 is 1 value less than 15. So I am going to plot it not directly on the notch of 15, but really close to it. So it would look somewhere around here. That dot right there represents the value of 14, and you can see how it represents it accurately in reference to 10 and 15 and all other numbers. Same logic for the rest. -25 means to the left of 0 and 25 spaces. In this case, -25 does fall on a notch, so that is very easy to plot, and it is directly on that intersection. Next is 7, similar to 14. It is a positive number, so to the right of 0, and it is somewhere between the values of 5 and 10. 7 is about one of the numbers in the middle of 5 and 10, a little bit more to the right, and it would be plotted here. -18 is to the left of 0, and it is plotted somewhere between -15 and -20. So it is plotted around here. -18 is closer to -20. So it is more towards that side. And finally 1 as you can imagine, is plotted immediately after the 0 between 0 and 5. So right there. So now I have plotted those points, and just like before, I am going to write them in order from right to left because it is asking for greatest to least. So I start with the rightmost number, which is 14, followed by 7, followed by 1, then negative 18 and negative 25. And that is how to use the number line to order them from greatest to least. And that was today's lesson on Introduction to Integers and Signed Numbers, where we also talked about positive and negative numbers and the number line. I hope this video was helpful. It was a bit of a shorter one this time around. Thank you guys so much for watching, and I'll see you all in the next video.